this is the basic outline for the image processing geometric transformation. First of all, we talk about introduction, then image deformation model, then image wrapping, and what is image registration and what is image morphing. After that, we will further continue on what is geometric transformation. So for the image processing operations, we have discussed modify the color values of pixel in a given image. With geometric transform, we modify the position of pixel in an image but keep their colors unchanged to create a special effect. Why we do this geometric transformation? Because we want to create a special effects to register two images taken of the same scene at different times to morph one image to another. How to define a geometric transformation? First of all, let u comma v represent the image coordinate in an original image and x comma y in a deformed image. Deformed means wrapped image. We use a function pair to relate corresponding pixels in the two images. Forward mapping, this is forward mapping. X equals to x u comma v, y equals to y u comma v, or x equals to x u. Inverse mapping, this is inverse of the forward mapping. Same, we can see this formula here. Fu comma v or fu, this is fu is the short form of fu comma v, denote the original image, and gx comma y or gx the deformed image. Okay, then they are related by this formula, this given formula, as you can see that. Illustration of forward and inverse mapping function. This is the two-dimensional diagram for the wrapping of an image. From this diagram, you can see that this is the UV domain. After forward transformation, there is a rotation. You can see that. After the inverse transform in this x comma y image, you can again get the same image. Okay. Translation. What is translation? Translation is defined by the following mapping functions. These are the functions. These are the translation functions. Okay. And this is the two-dimensional representation of this translation function. And if we talk about matrix notation, then this is the matrix notation for the transformation function. Exactly, we can see from these equations. And this is the two-dimensional figure. This is also called pixel-based diagram. Now, this is another type of geometric transform. This is called scaling. Scaling means if you scale any pixel vertically or horizontally, then its shape and size gets changed. From this diagram, we can see that this is a rectangle pixel, and after the scaling by 1 upon 2, this become a rectangle form. Change rectangle form. Scale. This is a scaled version. And scaling is defined by this function. These functions. These are the scaling functions. And this is the matrix notation for the scaling. Okay. Sx, here this Sx is less than 1 and Sy is also less than 1. This represents a unification or shrinking. Means if you scaled pixel by less than 1 value, means 1 by 2, 1 by 4, then it is called this is, and if the scaling factor is greater, then it is called zoom. Zoom is exactly reverse of it. And this is another type of deformation. This is called rotation. Basically, if you rotate the picture by something like we see in this way, and this is the rotation function. Theta is the rotation angle, and these are the functions for the rotation. In matrix form, this is the rotation. R is unitary matrix. This is unitary matrix. If we find a magnitude of this will come. So friends, you get basic concept of geometric transformation. So I'll stop this conversation and soon with new concepts in digital image processing.